This is Mr. Anderson for Kellogg Community College. We're going to be looking today at the first of 5 videos for the Trigonometry, Chapter 3, Section 4. We're going to establish each identity, which means we're going to work on the left side of the equation, and using the trigonometric identities and properties, we will get that to simplify or compile down to the right-hand side. So have those formula sheets ready. They're listed in the book, and you should have copied them down in class, because here we go. Now, what we're going to do here is we're going to get this secant times sine equal to tangent. Now, one of the strategies is to write everything in terms of sine or cosine. So secant can be rewritten as 1 over cosine of theta, and 1 over cosine of theta times sine of theta. If we multiply top times top, bottom times bottom, we get sine of theta over cosine of theta. And the sine of theta over cosine of theta, by definition, is equal to tangent of theta. So we have established this identity that secant of theta times sine of theta is equal to tangent. For the second of 5 problems in this video, we are going to look at how to handle the square of a function. We can rewrite this problem like so. We keep the 1 the same, but instead of writing it this way, we're going to write this as cotangent of negative theta quantity squared. So this whole thing is squared, and we can use this. This is an equivalent function that we can say this entire thing would be squared. So this way we can apply our even odd rules inside here, because our even odd rule would then say that this is going to be 1 plus, inside this parenthesis, this is negative cotangent. Sorry, let me put COT instead of dropping the C there. Cotangent of theta, and this is still quantity squared. Now, if I decide to square this whole thing, negative times negative is positive, or negative 1 times negative 1 is positive, and cotangent times cotangent is just cotangent squared. So what's kind of neat is this is a way that we can use algebraic reasoning to kind of get rid of that negative right there. And so now we can put that square back into this problem. So cotangent squared theta is equal to cosecant squared theta by definition. And what's kind of neat about that is we can take to get this to be equal to the cosecant squared on the right hand side, because we're not quite done yet. You could take your cotangent squared theta and rewrite that as the cosecant squared theta minus 1, because that's an equivalent expression right there of cotangent squared theta. So now I've got 1 plus cosecant squared theta minus 1. The 1's simplify to 0, so now I have cosecant squared theta is now equal to cosecant squared theta. I have established the identity. So what's kind of neat about this is you're just trying to use the properties of these trigonometric identities to kind of figure out how to get the statements on the left to equal to the statement on the right. So for our third of 5 problems here, we are going to distribute the sign to each of these functions. So a little distribution property isn't going to hurt here. So I'm going to multiply my sine times cotangent. So I got sine of theta. And a good strategy too is to maybe try to turn this into sines and cosines. So cotangent would be cosine theta over sine of theta. And then sine of theta times tangent of theta is going to be sine of theta, and I'm going to rewrite tangent of theta as sine of theta over cosine of theta. And we're going to have some simplification here, because what this is going to make is this is going to make sine divided by sine, and so that gives me just cosine of theta. And over here I'm going to have sine squared theta over cosine of theta. Now, one trick that I'm going to employ here is I'm going to get a common denominator and put these two fractions together. So my goal for that is to try to see just maybe what will happen. I think that's going to be a lot of your work that you might be doing in this section, is just do some experimentation to try to figure out, like, well, what can I get? And If I do this, it's going to give me cosine squared theta in the numerator plus sine squared theta in the numerator, all over cosine of theta. Now, what we know from x squared plus y squared equals 1 from the definition of the unit circle, that's the same thing as cosine squared plus sine squared equals 1. So our numerator is now 1, our denominator is now cosine, and secant is defined by that. So this is now secant theta. Boom, we've established our identity. In problem 4, this really isn't as bad as you might think it is right here, because one of the interesting tricks is that if you have sine of u and times cosecant of u, sine and cosecant are reciprocal functions, which means that cosecant can be rewritten as 1 over sine of u. So sine of u times 1 over sine of u, the signs simplify, so this I get 1 minus cosine squared u equals sine squared u, which is an equivalent expression of sine squared u. See, this is sine squared u is, you can actually move the 1 to the other side and get an equivalent expression here. This is solved right at that step, because 1 minus cosine squared u is the same thing as sine squared u. If you're wondering where that's coming from, if you take your sine squared u plus cosine squared u equals 1, which is a trig identity, you subtract the cosine squared u from both sides, and then I have my sine squared u is equal to 1 minus cosine squared u. And that's where you can see where I could go from here in this part right there and just automatically say, oh, that's our sine squared u. All right, now our last trick is going to be a good one, because this is a FOIL problem, but this is a difference. And what's great about the differences is that what you get is the first term quantity squared, so cosecant squared theta, and also minus 1. Now, what I'm not showing is the full FOIL. I'm not showing the full FOIL because this would be cosecant squared theta plus cosecant minus cosecant and then minus 1. So the middle two terms simplify to 0 when you do a FOIL problem. Now, this isn't quite cotangent squared yet, so what I'm going to do is I'm going to rewrite cosecant squared theta as this expression. The expression that's equivalent to cosecant squared theta is cotangent squared theta plus 1 minus 1, and the plus 1 and the minus 1 simplify, so now all I have left is cotangent squared theta. Boom, it checks out with what we did there. All right, this has been the first of 5 videos that will do the establishing identities in this section. These identities will get more tricky as they go, and remember, the best way to get good at trig identities is just to practice, practice, practice. The more you do, the better you get, and your short-term memory will also erase what you did, so doing old problems you've done before is very helpful. Thank you very much.